I feel like I kind of rushed through steps 4 and 5, so I want to go through them real slow for you right quick. Step 4, we're going to be graphing our function. So the first things first, we have our y-intercept, which is 0, 4, and our asymptote, which is y equals 3. Then we have our first point, 1, 3.5, and our second point, -1, 5. Then we trace our graph right there. Now, as you follow the graph going from left to right, you see it's in decreasing fashion. A decreasing graph tells me that I got to flip the range on my end behavior. So what is my domain and my range? Well, my domain is always going to be all real numbers, while my range is 3 to infinity. And I know it's 3 to infinity because since my a is positive, in front of my equation, my a is positive. Well, actually, I don't have an a, so automatically a is positive. So since that's the case, my range is my value for k to infinity. My value for k is 3, so my range is 3 to infinity. Now look at my end behavior. On my end behavior, it's made up of my domain and my range values. But since my graph is decreasing, I got to flip my range. So this is the first value in my domain. This is the second value in my domain. And like I said, because I got to flip my range, now my first value goes here and my second value goes here. If this was an increasing graph, it'll be first and second. But since it's decreasing, the first is here and the second is here. Let's look at the next example. Y equals 2 to the x plus 1 power. First step, we're going to find our x and my y intercepts. X-intercept, substitute 0 for y and solve. So where my y is, we go substitute in for 0. So now we have 0 plus 2 to the x plus 1 power. So now we go log base 2 of 0 equals log base 2 of 2 to the x plus 1 power. Now, just going from there, I know I have a log of 0 here. So since I have a log of 0 here, I don't have an x-intercept. So now I'm checking out my y-intercept. My y-intercept, I'm substituting 0 for x. So we have y equals 2 to the 0 plus 1 power. 0 plus 1 gives me 1, and 2 to the 1 power is 2. So since y equals 2, my y-intercept is 0, 2. Let's look at my asymptote. Now, I don't have a value for k here, so k will be 0. Since my value for k is 0, my y-intercept is y equals 0. Let's check out my input-output table. Once again, I chose -1 and 1 for my x values. So I plugged in and I solved it. Here, we plugged in -1 for x. So -1 plus 1 give us 0. So we have y equals 2 to the 0 power. Anything raised to the 0 power is 1. So my first value is -1, 1. Here, we plugged in y. 1. So now we have, where the x is, we have 1. So 1 plus 1 gives us 2. Y equals 2 squared. 2 squared is 4. So this value is 1, 4. So now we get ready to plot our graph. Here's my coordinate plane. Let's plot some points, shall we? Well, we know we don't have an x-intercept, but we do have a y-intercept. So my y-intercept was 0, 2, and my asymptote was y equals 0. So then we plot our additional points. 1, 4, -1, 1, and now we draw our graph line. And as you can see, my graph line goes from here to here, so it's increasing from left to right. Since my graph line is increasing, my range stays the same. The domain, as always, is all real numbers. My range is 0 to infinity. And my hidden behavior, first value of my domain, second value of my domain, first value of my range, second value of my range. Let's look at the third example. Y equals 4 to the x minus 2 power minus 3. Y equals 4 to the x minus 2 power minus 3. Once again, I always solve for x and y intercepts first. Y equals 4 to the x minus 2 power minus 3. Substitute in 0 for y. Now, once again, we do have to isolate the base. So since we're isolating the base, we're going to add 3 to both sides. When we do that, we have our new equation of 3 equals 4 to the x minus 2 power. Now we handle our exponent by changing to a logarithm. So since we had a base 4 here, our log is going to be base 4 here and here. Log base 4 of 4 cancels out to leave us with x minus 2. Over here we have log base 4 of 3. Now we do our change of base formula, ladies and gentlemen. Change of base formula simply is log of big number divided by log small number. So we have log 4 here plus 2. So change of base formula, log of 3 divided by log 4. Log 3 divided by log 4 plus 2. Log 3 divided by log 4 gives us 0.79. 0.79 plus 2 is 2.79 or 2.8. So my x-intercept is 2.80. Here, we're looking at our y-intercept, so we're going to plug in 0 for x. So now, where the x was is a 0. So we have 4 to the negative 2 power minus 3. So where the 4 to the negative 2 power was, we can convert that to 1 over 4 squared. 1 over 4 squared is 1 over 16. So we have 1/16 minus 3. And if you put in the calculator, you get negative 2.9. So my y-intercept is 0, negative 2.9. Once again, once you plug in 0 here in your y-intercept, you have 0 minus 2, which gives us negative 2. This negative 2 flips this number, so now this is a fraction, 1 over 4 squared, which is 1 over 16. 1/16 minus 3, simple math, negative 2.9. My asymptote, y equals k. My value for k is negative 3. So my asymptote is y equals negative 3. Looking at my input-output table, everything's pretty much works the same. I chose negative 1 and 1. We plug it in, and this is where we are now. Y equals 4 to the negative 1 minus 2 minus 3. Well, negative 1 minus 2 is negative 3. So 4 to the negative third power is 1 over 64. Now, because we have a fraction here, remember to subtract fractions, you got to change this 3 to a fraction with a base 64. Or you can just divide in your calculator 1 divided by 64, and 1 divided by 64 minus 3 is negative 2.98. Here, same thing, we have 1 minus 2. 1 minus 2 is negative 1. This converts to a fraction of 1/4. 1/4 minus 3. 1/4 minus 3 is negative 2.75. So this point is 1, negative 2.75. So step 4, we get to put these things on the coordinate plane. Our x-intercept, our y-intercept, and our additional point. There's my asymptote. There's my graph line. And watch how the graph line is drawn. It's increasing from left to right. Here's my domain. Always all real numbers. Here's my range. Negative 3 to infinity. And here's my end behavior. And because I have an increasing graph, my end behavior stays the same. Well, I hope this was able to help you guys. These videos will be posted on Edmodo, as well as the actual PowerPoint, so you can look through it slide by slide. There's an assignment waiting for you guys. It's a 4-question assignment. It's also posted on the Edmodo account. And Miss Britt, the instructor, will put the assignment up on the screen for you. Have a good one. Bye.